There we go. That's what I was waiting for. Unit 14, Day 3, Law of Cosines. Last week was Law of Sines. Today, Law of Cosines. And again, we'll use it to solve triangles. And again, it works for all triangles, so that's kind of nice. Let's see. So again, just draw any random triangle you like. Doesn't matter what shape it is. Doesn't really matter what angles you use or where you put them. But once you make it that far, it does matter where the sides go, because they've got to be across from their angles. So side A across from A, side B across from B, side C across from C. Up until now, what is c squared usually equal to when we're talking about triangles? Especially right triangles. A squared plus b squared. And that's sort of, that is the start of the law of cosines. That's not the law of cosines, that's Mr. Pythagoras gets credit for that. To adjust for it not being a right triangle, we put some more stuff on the end of this. So minus 2ab cosine of angle C. Hence the name law of cosines, because the cosine's in there. The key to making the law of cosines work is to make the angle and side that are across from each other in the picture be across from each other in the equation. If they're across from each other in the picture, they need to be across from each other in the equation. Now, because this works for any triangle, it doesn't matter if it's a right triangle or not, doesn't matter what the angles are, you can write law of cosines for the other angles as well. So if I wanted to write an equation that involved angle B instead of angle C, we kind of just follow the pattern. What side do you think will be over there by itself? B squared. And then I'll use the other two sides, so a squared plus c squared. I add these, but then I'm going to minus 2ac cosine of angle B. So, like, some people are like, oh, that's two separate equations. I'm like, nah, not really. It's just a matter of who's across from each other. And that means we could write one more. Cosine of angle A, well, a squared would be on the other side. Kind of follow the pattern. That means I need b squared plus c squared minus 2bc cosine of angle A. So there's our three, but it's not really three separate. It's kind of all the same. Law of cosines, three different ways to say it. And it's good to know the three different ways to say it, because if I give you a triangle that's not ABC, if I give you a triangle MAH or something, then it doesn't matter. You don't have to worry about it, as long as the angle that you want to use is across from the side that's by itself. Let me say this ahead of time. Remember that anything with more than, well, no, I shouldn't say that. Those were the cases that led to law of sines. These are the cases that lead the law of cosines. So again, I'm talking about how to pick which one to use. Today you don't really have to pick because it's the law of cosines day, so they're all law of cosines problems, so you don't have to worry about that. But eventually you have to know which one to use. The easiest way, though, is not to memorize this. The easiest way is if you know an angle-side pair, use law of sines. If you don't know an angle-side pair, use law of cosines. So I'll show you what that means in this problem. A equals 16, B equals 10, angle C equals 110 degrees. Solve the triangle. Oh, I guess the good news is there's no ambiguous case for law of cosines, so there's nothing weird, other than the algebra is harder. So probably what gets most of the people on this test is the algebra associated with these equations, moving things around, because there's a lot more going on in law of sines. So, I mean, it's not the pre-cal. The pre-cal, plus it's open note, so you'll have the equation. It's really the algebra of moving things around. Let's draw a picture. Side A is 16, side B is 10. Angle C is 110. So again, kind of two ways to think about it. It's side angle side, so that means it's law of cosines. But you could also look for an angle side pair, and we don't have any angle side pairs. So I can't use law of sines, so I guess I will use law of cosines. And since I know angle C, I guess I'll use angle C. So in fact, I'm going to start with that. Cosine of 110, that's... So again, rather than have three different formulas memorized, it's more like you know the shape, the format of the formula. So if 110's over here, then side C's got to be over here. And the other two sides are in the middle here, a squared plus b squared minus 2ab. But we know a and b, so this isn't too bad. So 16 squared plus 10 squared minus 2 times 16 times 10 times cosine of 110. All right, well, this is the easiest formulation of law of cosines because there's not much algebra to do. It's just straight type it in the calculator. So be careful, of course, but it's not tricky. It's just straightforward. Here's about the only problem for this one. So does C equal 465? No. What do I need to do? Square root that. C squared equals that. So square root of that, 21.574. Again, just type it in the calculator. Don't forget to square root it. Although, if you were paying attention and looking at your picture, and you try to tell me that this side is 10, this side is 16, and this side is 460, hopefully you'd realize, wait a minute, that doesn't seem right. Something is off. And then maybe you'd figure out what happened. All right, well, that was relatively easy to find side C. The trick is, now I need to find angle A or B. Question? Okay, so here's the trick. If you want to use the law of sines, you have to be careful because you don't know which answer it is. Right? Because when you use law of sines to find an angle, your calculator gives you one, but there's also the 180 minus, and you're kind of stuck on knowing which one it is. So I'm going to use the law of cosines to find an angle. So let's find angle A. Doesn't really matter which one we find. Cosine of angle A. That means a squared better be on the other side. So b squared plus c squared minus 2bc cosine of A. Because the a's have to be across from each other. Now, this one's a little different because I know all the sides. I'm looking for an angle. So let's fill in the pieces. Yeah, A is 16, B is 10, C is 21.574. And then what happens next is usually the place where people break down because their Algebra 1 skills have rotted, I guess. Or maybe they never were there, I don't know. But I've got to get cosine of angle A by itself. So let's move over the 10 squared and the 21.574 squared. Subtract them over. Getting closer. Trying to get cosine of angle A by itself. What should I do next to get cosine of A by itself? How am I going to get rid of this stuff? What did you say? I think you said it right. I'm going to divide it first. I guess exactly when you go to the calculator is kind of up to you. But the main thing is, yes, we need to divide it. And I think what some people messes them up, they see a minus sign and they think, oh, well, I'll add it over. Like, well, no, because all of this stuff is multiplied together. So let's divide it to get it off of that side, including the negative. That's a good point about exactly when do you go to the calculator, and it's kind of up to you. But I would do all the algebra first and then go to the calculator. Speaking of going to the calculator, fraction bar, maybe. Careful with parentheses, maybe. I'll take the safe route on this one and do the fraction bar. If I can get it, I need F1. Oh, I wonder if this one doesn't have the fraction bar. Oh, I grabbed a calculator, doesn't have the fraction bar. Oh well. Just be careful with parentheses. 16 squared minus 10 squared minus 21.574 squared. Close parentheses to get it all in the top. Divided by open parentheses to get it all in the bottom. Or if you're borrowing one of my calculators, the fraction bar means you don't have to worry about it.
So the fraction bar, can you just do alpha F1?
You can, but that wasn't working for my calculator. Yeah, it was supposed to be alpha F1. So alpha, right? A, I hit alpha. F1, it takes me to y equals. It could be an operating system thing, like it's also on the newer calculators. It's not on the older ones, or maybe this calculator itself is just bad. But whatever. So I get to there. So cosine of A equals 0.717. So how do I figure out what angle A is? Inverse cosine. If I'm looking for an angle, it's going to be inverse cosine. So inverse cosine of all of that. But I'm not going to type that in. I'm just going to use what's in the calculator. Inverse cosine of answer. And so there's my angle A. 44.180. So that's what I mean by cosine's a little bit harder to deal with, like algebraically. I'll move things around. I still lack one angle. How would you like to find angle B? Good. You can use law of cosines again if you want, but let's just subtract it from 180. I guess if you really wanted to go all out, you could use law of cosines and then make sure they add to 180. But who's got time for that? Let's just subtract from 180. Minus 110 minus 44.18, 25.82. And again, the check about biggest side, biggest angle, that's still true. So biggest angle is across from biggest angle, biggest side, smallest angle, smallest side. Doesn't guarantee I got it right, but at least I'm on the right track. Let's do one more, because there's basically two things that can happen, or two situations that lead to law of cosines, SSS and SAS. This first example was side angle side problem. So example 2 is going to be a side 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 problem. A equals 20, B equals 15, C equals 8.3. Again, I guess you could get by without drawing the picture, but and 8.3, and I don't know any angles, so which angle do you want to find? It doesn't matter. Somebody call that A, so we'll find angle A. That means I need cosine of angle A if I want to find angle A. What does that mean for the side that's over here by itself? Again, rather than like memorizing 3 formulas or trying to match up 3 formulas, know the format of the formula. And so A across from A, I'll use side A over there. And then I'll fill in with the other two sides. So 15 squared plus 8.3 squared minus 2 times 15 times 8.3 times cosine of angle A. All right, I'm going to pause it. You see if you can move things around and figure out what angle A is. So hopefully you got to here where you subtracted over the 15 squared, subtract over the 8.3 squared, then divide by what's left. Inverse cosine of that tells me what angle A is. 115.223. Uh-oh. Didn't get that? Check all your signs. Did you divide by negative? It's okay. It's why we're here. It's why we're doing it. All right, so we got angle A, 115. What angle would you like to find next? Angle C it is. You want to do B? It doesn't matter which one you do, because you'll do 180 to get the last one. So, sorry, you've been outvoted. We're doing angle B. So, this time I'm going to stop even short of setting it up. It's going to say we're going to find angle B. So you set it up, put all the things in the right places, move them around, inverse cosine, and see if you can get angle B. So I'm going to pause and see if you can really finish it out from there, because once you have angle B, then you can subtract 180 to find the last angle, and then you're done. So hopefully it looked something like that. The setup did. Move things around carefully, again, showing as much algebra as you need to show. I would probably show all of that because there's just a lot of pieces going on. So put that in the calculator with the fraction bar, inverse cosine of your answer. Angle B is 42.726. And then I can do 180 minus the 2 that I know to find the last angle. So, law of cosines versus law of sines. Everything today is law of cosines, so you don't have to worry about it. But just in general, you look for law of sines first. If you have an angle side pair that you know, go with law of sines. If you don't have an angle side pair that you know, then you're stuck with law of cosines. It's a little bit more complicated, but it's more straightforward because there's no ambiguity. There's nothing you have to worry about. All right, so careful today. It's worksheet 4 is today's assignment, so we're a little out of order. So when you look in the worksheet packet, worksheet 2 we just did. Worksheet 3 we'll come back to. Word problems. Be careful, there's one in here that says notes. We haven't done that yet. You can skip that one. So make sure you get to worksheet 4 for today's assignment. I mean, it says laws of cosines on there. It's just out of order. So make sure you find the right worksheet to do. 12 problems. I will have answers to some of them posted shortly.